meeting, and I will kick the recording off. Oh, Gianluca's already started the recording. Fantastic. I guess I'll take hosting duties this week. So there are a number of things that we're going to kind of cover this week. Our recording has already started. Thank you very much, as I mentioned, everybody for joining. For anybody who's joining for the first time, we have a code of conduct that's part of these meetings, but the TLDR is, this is a safe space. Make sure everybody, kind of ensure that we all look after one another. So thank you very much. With that, we'll start to go through the topics for this week's contributors meeting. First on the list is Nicholas Frahm.
Yeah, that's me. Hi. I'm new to the circle. I stumbled upon Tinkerbell a couple of weeks ago or a month ago, I think, when Alex Ellis was talking about it. Like, he's quite a big number when it comes to ARM and especially Raspberry Pis. So I have my own Kubernetes K3s cluster actually running here, and I'm looking to automate it a little more. And I was looking into Tinkerbell and how to provision nodes, and I saw some examples online on GitHub how that could be done, but they all require somehow UEFI. And I was wondering if there's some optimizations that can be done so it can be done or integrated with something like U-boot, or if it's possible to, for example, because I'm not so much in depth with net booting. I'm not exactly an expert. So like if you boot from drive and the drive is not provisioned yet, then it should also automatically net boot into your into Tinkerbell and then run the workflow. Or the other way around, if you don't have a workflow defined for this machine, it should, because otherwise you're required, for example, on Raspberry Pi, you can set a specific boot order. And the issue there is you can set a static boot order, and then ideally you don't want to modify it afterwards. The same if you have a consumer hardware. So you just configure in your UEFI the boot order once, and then you let it sit like that for the whole time because you don't have access via IPMI or something like that. So the idea is that...
Yeah. Sorry, I was listening.
Yeah, the idea is kind of that if it's possible, because I don't know if that's currently the case, if that by default you net boot, and then if the flag is not set in Hegel to net boot or allow net boot, that it then boots to hard drive, or is that currently the case?
So there's typically two ways that we see kind of people using it. One is boot from disk, with network booting being the second option. And most hardware, consumer hardware, even things like laptops and whatnot, if there is nothing present on the disk, then the BIOS will move to network booting next, at which point Tinkerbell will have a hardware profile for that and a template to run against it, at which point it will provision and write to that disk. And then upon completion of that workflow, rebooting of that node will then cause the BIOS to kind of relook everything. It will find the operating system on the hard disk and boot from there. And then from a deprovisioning perspective, it's a case then of removing things like the partition table, or doing a kind of low-level wipe of the hard drive so that it's blank again, forcing a reboot, at which point the BIOS won't find anything to boot from disk, at which point it will go back to a network boot again, at which point Tinkerbell could provision something different on that piece of infrastructure.
So for deprovisioning, how would you run the wipe? As a workflow? Because the issue is that still your hard drive is provisioned and you can't change the boot order on consumer hardware.
So yeah, I mean, the typical ways of doing that, you can effectively pivot what's actually running into memory, then wipe the underlying disk, and then do well, with everything in memory, you can actually then just do a normal top of reboot, or alternatively, you can pass a character to /proc/sysrq, which will force the kernel, which is loaded in memory, to effectively reset that piece of infrastructure, at which point then the boot process will start again.
Okay. But I guess that's that's something that you would have to implement on top, like your operating system would have to support it. Like you would do it, or you would do it via something like Ansible. I'm just trying to understand the workflow here.
I mean, there's a number of different ways that you could take care of it. From a manual perspective, when you've finished with one operating system, you would need to wipe that one way or another. I'm pretty sure things like Raspberry Pis do have some level of firmware tools, so CLI, that will allow you to change the boot order from userland.
Okay, yeah, you could run that via Ansible then.
Yep.
Yeah, fair. Okay. And then you would have to run that again. Okay, that works.
Yeah, that's one way of doing it. But yes, without things like an out-of-band controller, to a certain degree with consumer hardware, we are limited to either having a planned set of behaviors, so nothing on disk, then boot from net. If there is something on disk, then boot from disk, or doing semi-hacky things and whatnot in order to get things to behave like they would if we did have out-of-band controllers.
Is there some possibility to, I mean, you develop the architecture as microservices and ideally you want to have loose coupling, but is it possible to, for example, instruct OC to boot from hard drive if the allow netboot flag is not set in Hegel?
Yes, so OC effectively will, yeah, so OC could do things like a kexec. So if we had some level of workflow that looked for an installed operating system, it could pivot over to what it finds on the disk.
But that would have to be a workflow then too, I guess.
Yes, so we could effectively install an operating system but no bootloader, and then always boot from Tinkerbell. At which point we could have a workflow that then examines what's on disk, and if it finds something, boots to what it finds on disk.
Okay.
It's possible. Yeah, it's going to take some thought process to kind of actually do something kind of quite crazy like that, but that's typically what we find ourselves doing anyway.
Okay, that's very interesting because I'm due to do my master thesis soon, and I'm planning to build a hat/cluster board for Raspberry Pis. There's stuff like that, but they usually only support compute modules, and especially when you like start out with a single Raspberry Pi, you don't buy a compute module straight away, and you might have some old Raspberry Pis lying around. So I thought like a hat is like a better piece of hardware that you want to go with. And then my idea was to set it up so that you have some kind of remote control over these Raspberry Pis, the power control and potentially also boot order. But I mean, power control is like the minimum viable product there, basically. So I was curious how to do it on consumer hardware / Raspberry Pis.
Yeah.
Documentation like this, would you be interested in adding this to the Tinkerbell website? Because I think this is very valuable knowledge if you want to integrate with Tinkerbell.
Yes, absolutely. There are quite a few areas where documentation is lacking at the moment, and kind of the more that we start to kind of do, or we have end users wanting to do more crazy things with Tinkerbell, we will welcome anything that is useful for other end users for Tinkerbell. So if you have ideas and things that you play with that think that might be good, then please feel free to submit a PR or open a proposal as part of the Tinkerbell proposals, and we can kind of either discuss this further. Maybe it's something we could implement directly into Tinkerbell, or if it is just additional documentation so other people can do different things with Tinkerbell, then that's all welcome.
Yeah, I mean, I would be totally up for like putting in some documentation, especially like how to integrate with consumer hardware, because I think it's a very powerful piece of software that you've written with Tinkerbell, and I think it could be cool if you can do it with consumer hardware too.
Yeah, absolutely. I mean, Alex Ellis already did a workflow with Raspberry Pis, and I don't think that's necessarily been played with over the last couple of months, but there's been a lot of work that we've been doing recently, which actually should make use of Raspberry Pis much easier, actually.
Sweet.
Yeah, there is another link I shared on chat from Container Solution about their experimentation with the Raspberry Pi 4, as Dan pointed out, is probably not that new and up to date, and it doesn't have the full life cycle like the one you described with how to get from netbooting from and to disk and the other way around. But it may be a good start.
Yeah, this is the one I looked at, and the issue that I have with this a little bit is that it uses UEFI. So, and with UEFI, you have limited hardware support for some of the things on the Raspberry Pi. So I looked into the limitations of the UEFI project, and I wasn't quite happy with that. So yeah, but I'll have a look and then maybe mess a bit around with it and throw in some documentation.
Along with that, I'll like to share something. So initially we have a flag that is allow workflow that is available in your hardware data JSON. And if that is set to false, you won't even boot into workflow mode, meaning you will always net boot, or you will not net boot initially. So that implementation is there in boots. So it always checks for that flag, and accordingly your workflow mode or is switched on or off. So I can share the link in the description, in the chat section. So that will probably help Nicholas.
Excellent.
That'll be perfect.
Excellent. Does anybody else have anything that they want to add based upon Nicholas's questions? Okay, fantastic. Thank you very much. I'm just going to quickly share my screen and discuss some work that we have been doing over the last week or so. Let me make this a little bit bigger. I don't know how illegible that will be, but I think I'll shrink that down as much as possible. So one of the things that we have been working on over the last week has been a reimagining of OC. So OC is the operating system that is sent to hosts that are provisioned by Tinkerbell. And OC is loaded over Pixie, over TFTP, and it's a kernel and a RAM disk. And in that RAM disk is a bunch of files, and it will install Docker and containerd, and then it will start the Tink worker, and then it will do all of the steps in a workflow that is assigned to it. One of the, so it's based on Alpine, and when you do a build, it will recompile kernels, and it will get various modules, and it'll build init RAMFSs and things like that. We decided we'd investigate whether there was kind of a quicker way and a more modular way, instead of having to compile various bits and put them together, what alternatives we could possibly look at in order to do the same sort of thing. So we have put together essentially a proof of concept running using Linux kit. I'll kick a build off just so we can see how quick it is. So underneath now, I'm actually doing a build, and what's going to happen here is it's actually going to build for us a kernel and a RAM disk that have all of the components in there in order for us to run basically a different version of OC. So the way that it works, the way that Linux Kit works, is that it will build a distro as such from containers. So instead of installing stuff and things like that, you basically put what you want to run inside a container. It will then take those containers and munge them together into a RAM disk, and that is effectively what will be loaded by a server that you're actually provisioning. It allows us to be kind of quite quick, so it's already building the actual output. There we go, that's done. It takes around 47 seconds for us to build a brand new OC with all of those components in it, which is significantly quicker than the way that it is at the moment. There's a couple of things that we've added in here. So we've added in 2 containers of our own that we've built. Tink Docker is the container that is actually started first, and inside there is the Docker engine. So effectively what happens in this container is it will get the certificates from Tinkerbell, which allows us to do TLS with the registry. It puts that in the correct place, and it will start a watch for a file called Reboot being placed in /worker. Now, this is important later on, I'll come to this, but one of the biggest problems we've had for quite a while with Tinkerbell is doing a graceful reboot at the end of running your workflow. And then the final step is it will actually bring up the Docker engine. the other container, which we've called bootkit, these could all change at some point or another. Bootkit's role is to basically pass all of the information from Tinkerbell. So the Tinkerbell server, the gRPC endpoints, all of those sorts of things. It will then build a Docker container through the API. And we can see here we bind mount var and Docker inside that. And effectively, Bootkit then can speak to the Tink Docker container and tell it to start the Tink worker container with all of the correct configuration from Tinkerbell. At which point, we basically have a different version of OC running. And then the workflow will operate as expected. As I mentioned, it's much quicker for us to work in this fashion. It takes 47 seconds to build the thing. And the additional functionality in here is that we can now add a final action to a workflow, which basically just does a touch of the file/worker reboot. That will end successfully, so that workflow will be marked as completed successfully, at which point the Tink Docker process will cause a reboot of the operating system, a graceful reboot, at which point you will then reboot into your newly provisioned operating system. So this has kind of managed to modernize things and also fix some of the problems that we've had for a little while. So that's one of the things that we've been working on. And it's a slot-in replacement for OC. So we can see here it'll build a kernel and it will build a RAM disk. We can rename those and move those into the OC directory where the kernel and RAM disk are. And then Tinkerbell will basically pass those over to a newly provisioned system to boot from. And I will be doing a demo of this a little bit later on as well. But yeah, that's a reimagining of OC. We're going to give it a proper name at some point or another. At the moment, it's still called No Name. We're not very good at marketing from that perspective. We have a few suggestions, but if anybody has any great ideas, I'd love to hear them.
Cool. I don't have any good name ideas, but I have a couple questions.
Sure.
How easy is it to reconfigure and recompile the kernel?
So Linux Kit have already done, so there's a few things that we can actually do. We can keep the stock Linux Kit kernel, and then we can easily build additional modules for additional driver functionality. And those can be added as part of the init process. And then ModProbe will load those in built against this kernel.
Okay, cool. Yeah, because that's I looked at that, and like for the EM, like the Equinix Metal case, right? We need the Metronome. Sorry, no, that's a different NIC. The Pensando NICs.
Pensando NICs.
And yeah, and so those aren't built by default. So I was wondering how difficult or not it would be to kind of add that in. So that sounds nice. And the other question, I think you mentioned like the Tink. What was it? The Tink something process?
The Tink Docker process.
Tink Docker. That's running outside of containers or as a container, or?
So Tink Docker runs as a container. So everything runs as containers. Basically, the init process of Linux Kit is container D, and then it will start all of these processes in their own container D container. So DHCP, it will start a Tink Docker process. So it's basically it's Docker in container D.
Yeah.
But we pass then kind of all the capabilities. It binds directly to net. We also bind a bunch of directories to it so that it can access the underlying file systems and things like that.
Is the reboot handling thing that's done with like the echoing to the sysrec file?
Not anymore. No. Nope.
Oh, that's nice.
Yeah.
How does that work?
So in the Tink Docker, we pass PID host, which means that it is running, it can see all of the underlying processes. And if I actually look at the code here,
you send a signal to Docker.
We can just do a sbin reboot. And the syscall for reboot will actually then send a sig int or sig hup or whatever to process 1, which means we'll do a graceful proper reboot.
Okay. I was hoping to I was hoping. Do you know if there's any way to extend that or anything? Because I still want to do the kexec functionality, which I don't think there's any way to do it within a container. I remember I looked into it back in the day when I first did kexec and Aussie proper, and then kind of recently, kind of over the top, did a quick search to see if anything has changed with that in the kernel, and it seems like it didn't. And so my plan for Aussie was to kind of run TinkWorker either as without a container, as a straight up service, so that it can do kexec, or something else.
I'm not sure yet.
Okay.
But I mean, in order for this to actually happen, we need something to actually write this file to the disk. It can be ignored. We could have a file /worker kexec, and if we can do it, then it will then just pivot in that direction.
I think one of the follow-up that we can have with this model is to actually don't use a file, but to maybe have a socket and a more proper abstraction that's an underlying action can submit a set of commands to. So if we need sbin reboot, it can be sbin reboot. If we can figure out like a different way or different features we need, we can probably have that.
Yeah, I don't think that's the hard part. I think the hard part is just that since init is Docker, and reboot just kind of does tell init whatever signal, and that just by convention means reboot versus power off or stuff like that, we might have to kind of, I mean, for the Equinix metal case at least, we'd have to kind of figure out a way to kind of signal that we want kexec as opposed to a reboot or something.
Yeah,
we could do that. We could have something in here that isn't managed by containerd. So this init process starts containerd.
Oh, okay.
We could have something else.
That makes things, then that would be most likely that had to be the way to go, I think.
Yeah.
Like I said, like I remember that the kernel didn't let you do the kexec syscall with any kind of capabilities or anything like that. It was kind of like locked down so that it wasn't allowed from a container's perspective.
Yeah, we could certainly do something with it. I don't see why not.
Yeah, awesome.
Cool.
I certainly look forward to cleaning up Aussie in that makefile.
Thank you very much. Next on the list is me again. So one of the things I wanted to actually discuss, and it's been asked for by quite a few people, is to change the time zones of the meetings. So at the moment, we basically have this meeting every other week. And this one is friendly for people in Europe, Middle East, and kind of East Coast US. But for West Coast, it's just 2 hours too early, really, or 3 hours too early for most people. So my suggestion is that we basically alternate between this meeting and a later meeting in a bi-weekly fashion, so that we can have a later on meeting that people in the US would be easier for them to join. Does anybody have any strong feelings about that, or is that, I've got one thumbs up. I can't really see everybody else. One thumbs up, one SGTM. Okay, two, there we go, many thumbs up. Okay, that's fine. So we will look at moving, we'll keep in one meeting every fortnight at this time, and then we'll move one meeting at a later time so that we can accommodate folks in the later time zone. Thank you very much. And with that, I am going to pass over to Matthias.
Hi, so yeah, I wanted to update that with JSON. In the past weeks, we've been also working for the Tinkerbell support in Cluster API. So we created JSON created the shim implementation, which allows you to create the hardware entries, templates, and workflows using the Kubernetes CRDs. And on top of that, I've built the Cluster API controller, which allows you to yeah, to basically create a Kubernetes clusters using the kubedm and the rest of the cluster API. So yeah, we have like PRs opened with the code for the reviews, and yeah, I'm not sure, Daniel, Dan, Jason, if you want to add something more.
Yeah, quickly. It's so the repo. There's a few PRs left to merge, I believe. Is that correct?
That's correct. I'm going to be working on getting those sorted out this week.
That's fine. There's no massive rush, but yeah. So I'll just kind of quickly paste this in the chat. For those that aren't aware, actually, of what cluster API actually is, I don't know if Jason wants to give a quick overview, just in case people have not come across cluster API before.
Sure, yeah. Basically, it's just a declarative way of managing Kubernetes clusters using Kubernetes. So you can define what you want the infrastructure for your cluster to look like using Kubernetes style YAML, and it'll kind of make that happen.
Excellent.
That's probably the most generic way I can put it.
So yeah, this is essentially the technical preview for allowing a Kubernetes cluster to speak Tinkerbell and have Tinkerbell provision Kubernetes clusters as an end user. So it basically gives people the capability of having Tinkerbell fire out Kubernetes clusters as and where they need in their infrastructure, sitting next to kind of the other cluster API providers that already exist out there. So it's going to be like the same way that people are using. It's the same methodology, the same processes that people are now using to deploy clusters and things like cluster AWS, VMware, Azure, etc. They will now be able to take that sort of same behaviors and same logic, and then through the power of Tinkerbell, they'll be able to do the same thing with bare metal provisioning. So the technical preview, as mentioned, there are a few PRs left to merge. We had a fantastic demo of it last week, kind of all up and running. And yeah,
I can actually show a little bit, yeah, because I have like setup still running. So yeah, if you want, I can show you how it works roughly.
Sure, if that's okay with you.
Okay, so let me share my screen. I hope that works. Okay, there we go. Okay, can you see the terminal well?
Yep.
Okay, great. So yeah, right now I have the cluster already running. So wait, where am I? Right, so here I have the CapT controller running, and yeah, you can see that it's producing the oh yeah, it's yeah, there's like one like cluster which I need to remove. Anyway, but the controller is running, and yeah, I already have here. So I already have one cluster created, and it has 2 machines. You can see that the provider for those machines is Tinkerbell. Yeah, we can also list the Tinkerbell machine, which is like the type specific to the Tinkerbell. And yeah, like with kubectl, we can also get the hardware entries which we have from the cluster. Yeah, so in labels you can see that those machines are used by this cluster. Yeah, if we describe the machines to get like more information about them, then you can see that in the specification they're referred by the ID in the Tinkerbell, and then the shim which Jason wrote pulls the other information into the Kubernetes, so you can see that like what interfaces you have configured on the hardware, what capabilities it has, and so on. Yeah, so I think yeah, and here in the other terminal, I have access to the actual workload cluster. Yeah, so you can see the same two machines there. And yeah, they should have the, yeah, they have the same like provider IDs, like which we've seen in the other cluster. So let me actually like clean things up, and so we can kick off the provisioning again. So I'll remove all of that. That should release the hardware, so I can create the new workflows and so on. Yeah. Oh, and by the way, with kubectl now we can also look up the workflows which are created. Yeah, hopefully it will go away soon. There we go. So there should be no more clusters. Yeah, and like this is working together. So I'm running Tinkerbell with the libvirt at the moment. So it's all like virtualized on one beefy hardware managed with Terraform. So yeah, I just recreated all three machines which I have available. Now, if I list the hardware now, you can see that the labels has been removed, so that, like the hardware is available to create the workflows to be picked up by the controller again. And yeah, let's create a cluster. And when we create a cluster, you can see in the logs that the controller is like waiting for all the dependencies to show up. And soon we should see that it also selects the IP address like of the machine for the cluster, like the API endpoint. And soon after that, the machine controller, which is responsible for provisioning the machines, should oops, that's restarted. Yeah, so the machine controller should create a template and the workflow for all the machines in the cluster, like to start the provisioning process. So yeah, so you can see that the new template has been created. I'm not sure why the old one is still there. Yeah, so the template has a workflow it actually pulls the Ubuntu image and puts the cloud init data onto the like file system, which is installed on the disk. And then, yeah, it does some magic to reboot the machine and actually boot from the disk. So yeah, the last thing we need to do now is to look up which node to reboot. So reset 0. And now let me just look up which machine is it. Yeah, I think this one. And yeah, now we can see that we should see that here that yeah, that the machine will be booting to execute the workflow. Yeah, there we go. Yeah, like the new workflow also has been created here. Yeah, we can also get the workflow in the YAML format, and then like yeah, when it starts executing, you can also see in the events, you can see that each step of the workflow, like whether it has been executed successfully or it failed, and then why it failed, and so on. Yeah, so the provisioning currently takes some time, I don't know, around 10 minutes. And when it finished, you also need to deploy like some CNI, so the networking layer to the workflow cluster. This is not automated yet, but yeah, otherwise, yeah, you can see that like cluster creation and removal is yeah, is functional. Yeah, I think that's
excellent.
Yeah, that would be pretty much it. Some questions?
The workflow at the moment, is that hard coded in, or is that?
Yeah, so this is in the like there is one Go package which renders the workflow, which should take the cloud init and then install the Ubuntu with it. So, but yeah, this can be easily replaced with some other workflows.
Okay, cool.
Yeah, so there are like some shortcomings. So I created also a documentation PR of like how to get those things running, and there are annoying limitations right now. Like for example, the disk name must be like VDA, which is the virtual disk. So I think such things which we'll need to address that first, like to make it more flexible so people can also try it on the like regular hardware and so on.
Maddie, I have a question here. So, while executing the workflow, we used to get some events in the event table, right?
Yeah.
So, is it any cluster API to show those events?
Maybe I'll let Jason answer this question because I'm not sure.
Yeah, so right now we are publishing some of the data about the workflow, so it will show up the what actions have been run, what the status of those actions are, and things like that. It's not using the events directly right now for that. Mainly because we had an issue with where we had to disable the trigger for the events because it was exceeding the.
No, just to interrupt, I'm not talking about the actual event-driven process.
Okay.
Without the event-driven approach, uh, there's a workflow events table in the database. So for each action, it gets two kind of events: action started, or action finished, or failed, or timeout, right?
Yep.
And there is a CLI as well for that to get those events.
Yep, and all of those are basically correlated and put into the status of the workflow resource in the shim.
Yeah, right. This is what. Yeah.
Yep.
This is fine.
Yeah, so here you can see. So when I get the workflow in YAML format, then I can see the events and I can see the like I think what you were referring to. So yeah, state running,
yes,
state success, right. and so on. So yeah, you can still see that.
Yeah, right. So, are you using the same CLI or the same thing that we had in the database in the Tinkerbell, or you are using your own YAML or your own logic behind it?
But for what? For running Tinkerbell?
For these status of actions.
So it's making the same gRPC calls that the CLI is doing.
Okay, sure. Yeah.
Yep.
Thanks.
Yeah, so maybe I can also show that like the machine has provisioned, it rebooted, it runs Ubuntu, like the latest LTS. Yeah, and it's still in the provisioning state. But I think I should be able to access it already. So let's give it a try. Yeah, so Node has just been created and like there's no deployments yet, but like the cluster API is already like doing its things. Yeah, the pods are showing up. So yeah, soon the cluster should converge.
Epic.
More questions? I'll take that as no. So yeah, thanks. I think we can move to the next topic then.
Excellent work. That is epic. Cool. Thank you so much for that. I can't wait to kind of see where that goes. So the last topic for today is on actions. I have spent a little bit of time rewriting actions. 1 second, let me try and find the window. Right, cool. So one of the things that I have been looking at doing is the rewriting of actions in Go. We have on the Tinkerbell org a hub repository, and in the hub are some additional actions that we're going to be publishing. And the ones that I've added in recently, I don't know if I can see those. Oh, there they are. So two new actions. One of them hasn't been merged yet. One of them hopefully will be merged. But effectively, the two new actions, one of them is called Rutio. It again needs a different name. I don't really work in marketing. But Rutio, the main functional function of it is manipulation of disks. It's one binary that can operate in 3 different ways. So we can effectively pass to it a subcommand, and then it will parse the metadata and then act upon that. I can kind of quickly show you a workflow so you can see what that would look like. Just make this window a bit smaller. So if we look at the, might be easier if I. So if we look in here, oh no, this isn't the one that I modified. Nuts. I think I've updated the documentation then. Yes, here we go. So effectively, there are 3 actions that are in here. It's the same image, but the command that we specify will dictate the behavior of it. So for instance, if we pass it the command partition, it will parse the metadata and it will then write a partition table to the disk in the metadata. Format will put the file systems on there, and then mount will mount those file systems into the local container. This is effectively a drop-in replacement for what is called CPR, which is custom partitioning and RAID. So if you are already running all of the shell script that normally powers all of this, this is a drop-in replacement for this. It has taken the image down from 300 meg to 12, I think. And one of the things that I've been looking at doing is shrinking things down as much as possible for usage on edge devices and Raspberry Pis and things like that. So this should be a relatively easy way of having much more lower memory footprint for some of the in-memory bits of work that take place. The other action that I have been working on is image streaming. We saw briefly from Matthias, he's effectively doing the same sort of thing where he's pulling an image from somewhere and writing it to disk. This takes care of all of this. So this stream image is, again, a Go binary. It will do everything in memory. So it will basically do the pull of the image either from a, well, it'll pull it from a website, wherever that website is located, and then it will write it directly to the underlying storage that you present. The other thing that we can do, it needs to be converted to RAW. So it doesn't have QEMU image in there. It doesn't convert it inside the image. We can do that preemptively, but we can also then compress that raw image so that it's actually quite small for streaming back over again. And then it will, as part of the streaming and the writing to disk, it will do an inline decompressing as it writes that to disk as well. So I can give a quick demonstration of that. So this is a really small, ignore the name, I grabbed it from somewhere else. But effectively there's two actions in here. It's going to use a stream image. It's going to pull the latest version of Ubuntu. And it's going to write it to dev SDA, and then it's going to do a reboot action. So I created a workflow earlier. Yep. And I deleted the existing disk. So if I start this up, if I've done this right, let's make this a bit bigger. So this is actually going to use the different version of OC. You might catch the whale that's part of Linux Kit as it actually loads. But it should only take a few seconds or so. We can see it's already pulled the iPXE config. And then it will pull the Linux Kit kernel and the Linux Kit RAM disk. Come on. So here we go. There was the whale. We should see in a second it starts with the Docker engine. There's the Docker engine. It takes about 20 seconds to write this to disk. So in 26 seconds in the kernel clock, we should see some more Docker events. So at the moment, it's streaming that raw image directly to disk. It's done that, and it started and killed another container. It should reboot, which it's done successfully. It's now going to boot from disk. Live demo worked. And Ubuntu. So that is the new in-memory operating system that we put together, and that is image streaming as another way of deploying through actions. So yeah, those are two of the new actions that I've been working on. Another action that I'm looking at implementing is taking care of doing things like mounting that newly provisioned image and writing to that new file system so that the cloud init bits are already there as well, in the hope that it'll make kind of the work that Matthias has done a little bit easier, because it's quite hands-on to do these sorts of things at the moment. So does anybody have any questions around all of that? I'm going to be writing a lot more documentation around writing actions and how best to use them in the future, because the documentation is a little bit sparse around that at the moment.
Where does the metadata come from for the CPR thing? I saw there was a test environment variable or a test function that's being used.
So Rutio, here we go. So that will do somewhere in here. Ignore that, that's some leftover testing. If I set an environment variable, so it will do a retrieve data, which is here, where it will, that's not my wrong thing.
Oh, that's my code.
Yeah, I was looking at, I don't remember writing that. Metadata, here we go. It will look for the environment variable. These probably need renaming. I only wrote most of this like this morning, but it will get the environment variable of the Tinkerbell server. It will then get the metadata for that, and it will then pass it into the struct. It looks like this effectively generally, where it will then, if we pass the partition command, it will loop through all of these disks, and it will create all of these partitions for you. If we pass it the format command, then it will create all of these file systems. And if we pass it the mount command, it will actually mount them to these mount points. As I mentioned, it is quite small. I had to do some really quite interesting things to get it to work. So we do a load of building of static binaries to do that sort of thing. Some stuff we just can't do in Go. So making file systems and some of the swap stuff. Nobody's actually been bored enough to actually write this stuff natively in Go. So to keep them as small as possible, we build static binaries and then we copy them in to our Rutio container at the end, and we can shell out to those as part of the steps to actually do those actions.
Does an iPixie chain loader sound like something that should be actionified?
This is all after iPixie, so we don't really. This is all once the OS has been loaded.
I mean, like the secondary, like the chain loading iPixie. So to get a similar behavior to EM iPixie script URL behavior.
No, this isn't. This is well after iPixie's all of this.
Okay.
These are actions that are run by the Tink worker. iPixie has already handed off everything and loaded an operating system at this point.
Yeah, yeah. I just mean like the secondary iPixie. So if you have, what I'm thinking also is like I have in Equinix Metal a need to boot iPixie using stuff that would be in the metadata service. And so if I had an action here that could load the iPixie environment as like a secondary OS, then it could get me my third OS, which is what I boot from iPixie. So iPixie to boot iPixie to boot something else.
I have thoughts around this, right? This is part of the reasons why I have the workflow services proposal, and kind of like what I think what I call the self-contained workflows are. We can talk offline, and then I'm scheduled to start like redefining or like cleaning that up and actually getting to work on them. So I think that'll match your use case and will be something you want to see.
Okay, cool.
I have a question on this. I see that you're like using images from Quay. Is that a supported thing? Because I saw in the documentation on Tinkerbell.org that you're using the internal registry, but it's possible to pull from other places too for the actions?
It can be. Ideally, you would tag these images and upload them to the internal registry. Your machines would also need internet access in order for them for the Docker engine to go out and pull them from somewhere remote. So the easiest method is to tag them to the internal repo, and then give them the correct name in the workflow.
I actually want to get rid of the internal registry, especially for like in the sandbox and all that. It's just kind of makes things much more difficult. I think just setting up natting on your control plane machine or on the provisioner, and then it all just kind of works, and you can reach out to any kind of container host.
Yeah, I think historically. Oh, go ahead.
No, go ahead.
Yeah, I think it's historically we didn't understood that we understood that the Tinkerbell network was supposed to be not accessible from, like, it didn't have access to the internet. That's why we have an internal registry. It's still there, but we figured out it was not a strict requirement. So the NAT is in place now. So it really depends on how you want to use Tinkerbell. If you want to have it locked without internet access, you have access to the registry, but you will have to do some extra work on pull, tag, and push images in the registry you have access to. With Sandbox, this is not required anymore, so you can get images from wherever they are. It's on top of it's on you how you want to use it.
A Sandbox is what?
Oh, it's just a repo that has a few scripts that helps you to have a Vagrant or like Equinix Metal Tinkerbell stack up and running.
Okay.
But I mean, yeah, probably the documentation is a bit like old, and we didn't, or maybe we just forget to mention that the NAT is now in place. So you can have internet access if you want. And if you have internet access because you want it, you can get images from wherever they are.
I mean, like what I noticed is that like I basically started at Tinkerbell.org because when this whole thing came public, then that was the place to start with. But I feel like a lot of the documentation is all over the place, and I would be willing to kind of tie it together. Like if you could throw like all the links to the Markdown documents into some folder, then we could like I could throw it
They're all
together.
they're all in tinkerbell.org/ no, they're all in tinkerbell/docs.
Yeah,
Okay.
I think also a lot of what you saw this today got developed like in the last 2 weeks. So a lot of this is in our like brain right now. And overall, we have to do I think every once in a while I do a full week of documentation, writing documentation. So I'm sure at some point I will get back to that habit because there is a lot to say about like all the new stuff. But yeah, documentation ideally is where Mara pointed it. But a lot is spread in our mind still.
I mean, it is not at all like to be judging or anything. It's just like I would like to contribute, and like putting in documentation is like one of the easiest ways to contribute. So
yeah,
and I have plenty of time. So
oh yeah, I'm going to reach out because there's some heavy documentation.
Gianluca will be jumping on you.
Your book.
Excellent. We're coming to the top of the hour. I'd like to thank everybody for joining, and everybody I'd like to thank for the demonstrations that they've done today. For everybody that's new, I hope you've seen some interesting stuff and you've been given some ideas in terms of ideas where you'd like to see the project go or areas that you'd like to consider contributing to. Yeah, thank you very much, everybody. And we will be changing the meeting slightly as discussed earlier. So we'll be moving to a Europe and America's friendly split. And yeah, any questions or anything like that, we're all normally about on the Tinkerbell Slack. So thank you very much, everybody. Thank you all for joining and enjoy the rest of your day.
Thank you.
Bye. Thank you.
Thank you.
Bye-bye.
Thanks, bye.